Hey everybody, this is James Brown. I am a third year environmental engineering student here at ASU. I'm here to present to you the project Safe Water. Drink more water, drink it safely. And it's to you, the respectable people of Super Safe Drink Water Industries and Co. So what is the goal and motivation? The goal of this entire project is to have potable drinking water for everyone, reducing the amount of arsenic that is found in water. Arsenic can lead to cancer, skin lesions. It's terrible for cardiovascular disease. People can get diabetes. It's linked to negative impacts on cognitive development for kids. So what are we going to do? We're going to start out with the amount of arsenious or arsenic acid. We're going to reduce that in one section of the treatment process, and then we're going to take the arsenic that is then just paired with water and then reduce it with activated carbon. We're going to be solving for specific gravity, flow rate, and the amount of arsenic that is reduced within the system. So if you look at the bottom left, we have two influents. We have H2O hydroxide together going into one chamber, and then we also have arsenious acid going in the other. The first thing we're going to do is we're simply just going to write out the formula for the reaction. We're going to see that everything is 1-to-1 except for the hydroxide that comes out that reacts at the end. It's 3-to-1, but that's not totally important. We are told that 375 meters cubed per hour of ASO is entering the system. And we know because it's a 1-to-1 ratio that 375 meters cubed per hour is going to be exiting. All right, so that brings us to the second graph. So we now have the arsenic leaving. The hydroxide is just completely removed. All right, the first thing we're going to do with the activated carbon system is we're going to just label and define everything. There's a lot of flow rates. We're trying to make the flow rate that's going in equal to flow rate that's going out, so there's not going to be any other sort of stream that's leaving. So we're told that the amount of the amount of arsenic going in is 375 meters cubed per hour. We're going to multiply by the specific gravity and then divide by the molecular weight. We're going to get 100 kilomoles per hour. Then we're going to solve for all the flow rate balances, in equals out, right? Most importantly, the initial amount going in is equal to the amount going out, so that's not going to stop the amount, the flow rate of the drinkable water. We want to make sure that people are able to drink water. You know, it's important. Okay, so how much of the activated carbon is actually reducing the amount of arsenic in the water? Well, we're told in the problem that it's about 80% effective. So we know that about 0.4 moles per mole of arsenic is coming out. So that's a lot less. And in our final step, we're just gonna do a concentration balance. So mole fractions multiplied by flow rate is gonna equal mole fractions multiplied by flow rate out. And that's gonna get us 0.45. So that is indeed less than the amount of arsenic we had. So it's way more drinkable at 0.45 instead of 0.5. All right, thank you so much. How do I stop this?